I have a small collection of vintage computers, of the ones that predate things like the Apple, the Commodore, the TRS-80, and some of them are, while not unobtainium, are just awfully rich for what you get, and I have not purchased authentic examples of them. For example, my MITS Altair 8800 is not an original one, it's a clone, a very good clone. Can't tell the difference from the outsider by the way it works. And I'd kind of lusted after its counterpart, the IMSAI 8080, which was the first personal computer clone, cloning the MITS Altair 8800. And finally, a company in Australia called thehinibble.com produced a kit a few years back, probably more than a few years now, but I purchased one maybe a year and a half ago and got it in, and then other things intervened and I haven't touched it for more than a year, and now I finally got around to building it. The guy who runs the High Nibble started with previous work done by a guy named Udo Monk, where he had developed an IMSAI clone running on a different platform. And this guy now in Australia ported that guy's development code over to the ESP32 microcontroller, specifically the ESP32 Pico-kit. It's like a overgrown Arduino type of thing. It has a dual-core CPU at 240 megahertz, 520 kilobytes of static RAM, 4 megabytes of flash RAM, and a built-in Wi-Fi, built-in USB with UART, and so on. And to that he added a micro SD card for a FAT file system using a 16 gigabyte card, a PS RAM, that's a pseudo static RAM. It's really dynamic RAM, but it's configured to act like static RAM, and that allows for banked memory implementation. And he also added some things like a true RS-232 driver and a max 232 converter, so you get the proper RS-232 levels, and it actually has emulated 4 RS-232 ports, which would be 2 of the original IMSAI serial driver cards, and all sorts of other stuff. So it's a full-size, fully functional replica of the IMSAI CPA. As far as the front panel goes, very close approximation of the original. All the LEDs and switches. The whole thing's about 17 inches wide. So I did not plan to do a video on this. I was just doing a slideshow from my own archives and then tacked on a little video at the end. So this video is going to be just me cobbling some of that together in case it's of interest to anybody else. The entire kit comes in this cardboard box, which is perfectly sized to hold everything, and all you need to provide is a few basic hand tools and solder. And then you've got a nice double layer cardboard carrier that holds most of the components arrayed nicely like this. They don't come just jumbled in a bag, although the small electronic components are in a bag. Here are the contents of the parts bag laid out. A whole bunch of resistors, a whole bunch of LEDs, various connectors, jumpers, capacitors, and so on. The actual ICs and their socket or sockets are on the parts carrier, not in the bag. With a lot of kits I've built over the years, especially ones made by, hobbyists and, companies that are not, like Heathkit or something, I've often found that the LEDs provided are kind of crappy. They're not diffused, or they're poorly diffused, or they're weird looking or something, and I wanted to have the appropriate classic look. And it turns out the high nibble did spend some time trying to figure out the best looking LED that matched the original IMSAI computer as much as possible in appearance. But I didn't completely trust that, so I still powered one up and just checked it out myself to make sure I was happy with the way they looked. I don't have a specific photo of it, but inside this box, you can kind of see it around the top and the sides. There's an aluminum case. It's not the full depth of the original. It's just 2 or 3 inches deep, but it does help support the IMSAI front panel and give it the appropriate look from the front at least. And there's also a lot of acrylic pieces in there. There's the front fascia panel, various clear acrylic panels, black masking panels, structural panels. There's a lot of laser cut plastic in this kit. Okay, here's a look at the ESP32 Pico kit. Microcontroller. Lots of power on this little thing. Again, it's sort of like an Arduino type of thing, but more powerful than I think most of those. The thing on the left is a micro USB connector, and the oddly shaped thing at the right end is a Wi-Fi antenna. There's the bottom side of it. No parts on the bottom. Okay, the assembly starts now of the circuit board. There are only 2 surface mount type components, and this is one of them. It's the PS RAM or pseudo static RAM, so it's a really large dynamic RAM chip which is set up to behave like a static RAM IC, and it's connected serially to the controller, so it doesn't need all those pins. But this is the majority of the RAM right here that the controller uses for operation of the IMSAI. And the other part that is surface mount is the micro USB socket. This is for a RAM card, but it comes already loaded. It's non-volatile, so this is essentially the ROM images for all the different configurations the IMSAI can have. Then a resistor and a capacitor in support of the RAM chip. Then a resistor network, and the socket strips for the controller, the ESP32, which plugs in like this with the Wi-Fi antenna away from the edge of the board and the USB connector towards the corner of the board, like this. The pre-programmed SD card with all the ROM images plugs into the small connector on the circuit board there and snaps in. If you push it again, it pops out. Alright, the first test needs to be done before proceeding. I just have a USB cable plugged into the ESP32 controller. I'm looking in my Windows computer devices and finding in the instructions where I'm looking for a Silicon Labs indicator, and there I find it. It's assigned to COM3, and I'm setting up my Teraterm terminal emulator to point at COM3 and the Silicon devices as it says there, and noting the baud rate and the other settings from the instructions, I set up Teraterm's serial port with the 115200 baud rate and the 8 data bits, the none for polarity, and 1 stop bit. According to the instructions, I'm looking for some intelligible text and a lot of gibberish with intelligible text stuck in the middle of it, which I'm seeing a lot of. And there are certain errors that I'm looking for. There are some like can't find this or that, things that aren't installed yet, but I'm mostly looking for particular errors, especially unable to communicate with certain RAM and so on like that. I don't see any such errors here. Assembly continues with the LEDs. The kit comes with a couple of plastic alignment jigs, one to keep them spaced properly and not tilting, and also off the board by a requisite amount. And then second one lays on top of that just for additional alignment. And then you check to make sure all the LEDs are in with the right polarity according to the lead lengths and the markings on the silk screen of the circuit board. And then make sure the two jigs are level and not tilted. And then put a little masking tape on it to hold them in that position. And once that's ready, then you can solder the row of LEDs, clip the leads, and they should look like this. Same process is repeated 4 more times for 4 more banks of 8 LEDs, and there's also a half a bank of LEDs, so 4 more LEDs down in the corner. And this just shows how that's going together. And then all of those LEDs need their own current limiting resistors, which are soldered on and shown in these couple of photos. Next, using the ESP32 controller as a power source and a short jumper wire which is included with the kit, I go through and test all the LEDs by connecting the plus 5 volt power rail to the various pins of the place where the LED drivers will be connected. Then the various resistors for the switches, and also a bunch of small ceramic capacitors for decoupling on just about every IC on the board, front and rear. 4 of the capacitors in this last photo are actually the charge pump capacitors for the MAX 232 IC that will drive the RS-232 ports. That's required to get the requisite plus and minus voltages. Then all the IC sockets are soldered on, both front and the one on the rear. And then some other things are tacked on, including a small tactile switch for reset and some pin headers for shunt jumpers that are on the rear of the circuit board, mostly around the ESP32. The controller supports 4 serial ports, 2 of which are implemented by actual RS-232 ports, and the sockets for those have been soldered onto the board at this point. The other ports include the Wi-Fi on the ESP32 and also the USB port. Then all the digital logic ICs are plugged in on the front of the board, and the MAX 232 RS-232 interface IC goes on the rear of the board. It's time for some more testing before proceeding with the assembly. The ESP32 is plugged back into the back of the board and powered up over USB. The power switch is temporarily just stuck into its holes on the circuit board without soldering it. And the IMSAI to this point is powered up. And the jumper wires used, you can see the blue wire next to the power switch at the lower right-hand corner of the board. That's used to tickle some of the points where the various mode switches will be plugged in later in order to put the IMSAI into run, pause, do resets and things like that to exercise the all the LEDs in different ways. And there's also a test function which can be implemented to test the LEDs. There's a large piece of laser cut black acrylic which is considered to be the mask, and that's bolted to the circuit board now using 8 black button head screws and some nylon spacers and nylon nuts on the rear of the circuit board. In addition to acting as a light mask for better appearance of the front panel when that gets mounted on, the mask plate here also serves as an alignment jig for the switches when they get mounted in the next. One thing this kit gets right is that it uses the appropriate style and color of these at one time common and now kind of special toggle switches with the big paddle shaped operators on them. The first bank of switches is stuck in through the cutouts in the mask, and then one of the pieces of plastic that was used for the LED alignment does double duty to make sure the tips of the paddles are also spaced and aligned properly. And then that whole assembly is taped tight to the board, And the board is flipped over and all those switches are soldered. And then I just go through and exercise the switches through, all switches down and then all switches up. And then I just flip them in alternate directions just for the heck of it. The two other banks with switches are soldered on, or mounted and soldered on rather. And the leftmost 16 switches can either be up or down. There is no middle position, but the 5 switches to the right of that, which are mode switches, actually have a center position, and then they can be raised or lowered and their spring return to the center position. And then of course the power switch is the rightmost switch. That's not a paddle type, it's just a rocker switch. Now for the tests that are upcoming, the so-called fascia panel, that's the visible front panel with the big letters IMSAI 8080 and all the legends above the switches and LEDs, is temporarily laid in place, but it's not bolted up yet. Okay, this test is going to be to set the address with the switches, and first off I'm going to reset the IMSAI with the reset toggle, and then I'm going to make sure all the toggle switches for the address are set low, and then use the examine button to set that to the address bus, and that's reflected with the address LEDs, so they're all on. And then I'm going to set all the switches down, and once again use the examine switch to set all the address bits back to 0, and that's reflected by the LEDs. Now I'm going to use the run stop button or the run stop switch to toggle the IMSAI between its wait and run modes as reflected by the status LED. Now it's shown in the run position there. Next is the test procedure to actually load a program into the IMSAI and run it. And in this case, I'm just pulling up from the large ROM bank that's implemented in the non-volatile SD card that's plugged in. I pull up CPM, and that's done by setting the address switches to the pattern shown, and also doing a little dance with the execute button and the reset button on the side of the unit, and that gets it into CPM. Now very carefully, in a very tedious and fiddly operation, the bolts are undone and the extra layers of acrylic, including the front fascia panel, the clear acrylic that goes over that to protect it, and then a rear panel which is clear acrylic, and additional spacers are all put in there. And I actually had messed this up really badly twice and almost had to disassemble the thing and rebuild it. It is a mess, but it did get done eventually. This is the hardest part of assembling the kit. The remaining bit of chassis assembly includes mounting the so-called switch surround, which is another thick acrylic piece painted with a hammer tone finish to resemble the original, and that's attached with strips of Velcro so it can be removed. Sort of tacked onto the end of the assembly instructions, and also barely mentioned in the instructional videos online, are these reinforcing pieces which go on the front and back of each corner of the rear acrylic frame piece. That's for the captive nuts that are used to secure the whole sandwich assembly here to the outer aluminum frame. This step really should have been done before the rear acrylic panel was bolted into the sandwich. It would have been a lot easier, but with patience and super glue and a lot of cussing, I got it done. And here it's shown with the 4 screws going through the aluminum frame and then into the captive screws holding everything together. The reset button and also the SD card are accessible through ventilation slots in the side of the aluminum frame. Not really described at all, and just figured out by myself is that one of the 8 reinforcing pieces isn't a complete quarter of a circle and is just a truncated version. You can see it at the upper left here. And that's because if you had the full quadrant, it would block access to the USB port on the left side of the ESP32. All right, assembly is complete. Looks pretty good. The aluminum frame is large enough and heavy enough that it actually provides enough stability to operate the front panel switches just with it sitting there by gravity. So that's a nice feature. I was worried that I'd have to hold on to it whenever I moved the switches. And then there's another photo here with the newly completed IMSAI running CPM. The LEDs which appear dim here are because they're flickering. Those are address and data LEDs that are turning on and off rapidly as the program executes. That the program in this case is the CPM operating system. It's a simple matter to connect the ESP32 inside the IMSAI to a personal computer running Windows or Mac or whatever using the Wi-Fi connection. And it's just a matter of knowing the MAC address and then typing it into any browser, and it pulls up the so-called desktop user interface, which is a web app, and it's resident on the IMSAI itself. And it includes all sorts of utilities and applications and things. And here's just a picture of the system information screen that I pulled up from one of the icons on the IMSAI's desktop user interface. No computer of this vintage with the toggle switches and LEDs user interface, at least in its native form, none of that's complete if you don't actually use that at some point in time to play around with. And in this photo, I've loaded in the 24-byte classic program actually for the Altair 8800 computer, but since the IMSAI 8080 is a clone of the Altair, anything that runs on the one will run on the other. And it's the old classic kill the bit game, which I've loaded in and run. And if you could see this in a video form, you would realize that the left bank of 8 address LEDs over the left bank of switches is actually scrolling across, and the objective of the game is to raise the appropriate switches as the LED passes over to extinguish the scrolling LED. And if you screw up, then it adds more LEDs that are on, and it makes it even harder to win. It's also nice to be able to run an actual programming language on the computer, and so here I've used the ROM bank to boot up a version of BASIC, and then you can see the screen here. This is using the built-in monitor or terminal program that's built into the desktop. So I'm connected up over Wi-Fi, and I'm using the IMSAI's own desktop with its terminal emulator to enter and run a simple BASIC program. As an example of setting up to use BASIC just without the Wi-Fi or the desktop UI that comes with the IMSAI, here's a sequence of photos showing me going into Windows and selecting devices, and under that finding the IMSAI, which appears as the Silicon Labs CP210X, And then once that's established and I know the COM port associated with it, I go into my terminal emulator program and set it up to talk to that COM port, and with the appropriate baud rate, number of data bits, parity, stop bits, verifying that it's still looking at the Silicon Labs CP210X, and then going ahead and using BASIC via the Teraterm user interface instead of the terminal that's part of the IMSAI's desktop UI package. Alright, I have Kill the Bit game going on this. So this is the program running up here, but these 8 bits are the bits that we're supposed to kill. And the objective is to toggle one of these up just as the LED's over it to try to... If you get it wrong, then it makes a much more complicated pattern. Oh, there, I made it worse. Okay, stop, reset, run. Ah, got it. Killed the bit. Let's try that again. Stop, reset, run. Oh, no, I made it worse. Killed it. Stop, reset, run. I made it worse. Killed it. Well, at least the Kill the Bit program is working in the raw IMSAI programming environment. Toggle switches only. Alright, I've got the IMSAI Clone plugged into my computer by USB now instead of connected by Wi-Fi. I've just opened up Teraterm, and I need to select that it's a serial port, and I already know that it's the Silicon Labs CP2 whatever device that's on the ESP32 board inside the IMSAI as COM3, so that's appropriate. And I'm getting some stuff here. Having trouble expanding this window a little bit. Control, reset terminal, setup, serial port, there we go. It's got to be set up to 115200, 8 data bits, no parity, 1 stop bit. Make that a new setting. And I'm hunting around here trying to figure out how to expand this window a little bit. Alright, so if I turn this guy on, it should still be booting into BASIC. Bloop. There was something that happened there. Z80 sim. Because right now the IMSAI is not running, it's in wait mode, so I'm going to raise the run switch. There we go. I'm into BASIC. God, this camera has so much trouble taking pictures of this screen. We can look at the front, we can see there's all the data and address bus activity going on here. So I don't think I need to put in width here. I can just hit enter. End of memory, I have no idea. I've got 48K and change. There, that's a little better. Okay, let's put in. I won't show me typing this. I'm going to come back after I've typed the program. Okay, I've just put in a little for next loop there. I'm going to hit enter. I'm going to do a list. Okay. I'm going to run. It runs perfectly. So yeah, this is going to be my preferred way of getting into BASIC on the IMSAI. It's it seems to me a little less fussing around than doing it the other way. And both times when I've tried to connect the IMSAI to my computer through its Wi-Fi bridge, it seems to throw all my Wi-Fi printers off, and then I can't print to my Wi-Fi printers from my computer unless I restart Windows, which is a pain in the ass. So this is only a couple more mouse clicks to do it this way, and it doesn't mess with anything else on the computer. So anyway, it's no harder than that. Just knowing what the baud rate is and knowing where to look in Windows to see which COM port is being assigned to the USB that's plugged into the IMSAI. Those are the only two things. I decided to replace the 4 screws that came with the kit, the ones that secure the aluminum frame to the sandwich of circuit boards and acrylic panels. In the course of putting the reinforcing bits on the corners of the rear acrylic piece, a little bit of the glue got into a couple of the captive nuts, and the screws were really hard going in, and I was pretty much stripping off the Phillips heads of the screws. So I was able to get those out, and I ran a tap through the captive nuts to clear out the super glue, and bought some new screws with hex drives instead of Phillips drives, otherwise the same kind of screw as the originals. But I found out that in one instance the tap had ruined the nut, and so I couldn't use that. So my most expedient fix was to make a little aluminum bracket, which used a new hole just adjacent to the original hole, and then tapped into the 3-layer reinforcing piece at the corner. So that's what that looks like. Alright, I want to hang my IMSAI from the wall of my office in a way that I can easily unhook it when I want to demonstrate it. And I want to store its USB cord with it, but out of sight, so that I don't lose it, because it has that right angle fitting, and I don't have any other cables that would work. So that's all part of the plan. I've got my little sketch here. There will be a wooden wall bracket that screws to the drywall with a couple of screws going into drywall anchors, and that will go all the way from the wall to the back of the IMSAI's rear acrylic plate, and then along the top edge of the IMSAI's frame will be, I'm calling it the hook, but it's just another strip of wood that will attach with a couple of screws into the frame, and that will engage with a raised edge on the wall bracket. So by lifting the IMSAI about 1/4 of an inch, it can come detached. I just ripped the 2 pieces out of some select pine scrap that I had using the table saw and my router, and they're test fit. The hook is on the top, and here I'm comparing it to my scale drawn sketch to make sure that everything is the way I thought it would be. To mount the hook part to the frame of the IMSAI, I've put a couple of brass inserts. These are 632 size, and the wall bracket has a couple of holes drilled through it, countersunk on one side so I can put flush head screws in there. I've also notched out the bottom of it to clear a couple of the nylon nuts on the rear acrylic panel of the IMSAI. To hold the USB cable in its bundled configuration, I've cut a short piece of some Velcro hook and loop wire tie and put a hole through it. I'm going to secure it to the bottom of the wall bracket with a small sheet metal screw and a washer. I gave the hook part a shot of blue paint and the wall bracket part a shot of white paint. Alright, I'm mounting the hook portion to the IMSAI's frame, and there it is mounted, and here's a side view so you can see that it's offset from the rear acrylic panel. A small refinement here, there's a central hole on the center line of the hook where I've just countersunk the hole, and then the corresponding position on the wall bracket has a small button head screw screwed all the way in so just the head protrudes, and that'll help center the hook and the bracket when I'm mounting the IMSAI on the wall. So I can just slide it sideways until the screw head docks into the recess, and then I'll know it's centered. Here's the wall bracket, and you can see the protruding button head screw. It's black right in the center, and here I'm test fitting it to the hook that's mounted to the IMSAI. Seems to be working out pretty well. I've put the Velcro strip on the wall bracket, and here's how it's holding the USB cable, and here's how it goes when it's in docked position. There's just enough room for it between the acrylic rear panel of the IMSAI and the wall. I've installed a couple of drywall anchors into the wall just below my Apollo Disky clone. Seems like a good place for this thing to go. And then I've also got some paper taped up to the wall that goes down and then is bent around at the bottom to catch drywall debris, because a lot of computer equipment's right under this, and I didn't want all that debris to fall into the equipment. Alright, project complete. It looks good sitting there right below the Apollo Disky and right next to my desk, so I can marvel at it all the time. But yet it'll come off very easily if I want to take it down and use it, and everything I need is right there. Just plug it into the computer for power and USB connection and do some demos.